So far in the unit 1, we have studied about the combination logic circuits, their analysis and design. The process for combination circuit is first we have to draw the truth table when we are designing from the specifications given in the question. Then we have to solve with the help of K-map or tabulation method, and we have to implement it with the help of basic gates or NAND or NOR gate, which are both universal gates. Now today we are going to discuss the sequential logic circuits. So we have two types of circuits in digital electronics. First is the combinational circuits that we have studied so far, and another one is the sequential circuits. Now, before proceeding into the detail, first let us discuss what the sequential circuits are. In the combinational circuits, output is a function of present input. Whenever we give an input, the corresponding output will be there as per the mathematical or logical calculations, depending upon the logic circuits you are using. While in the sequential circuits, output is a function of present input and the past output or the past input. The circuit remembers past history and must contains a memory element. We have to either store the output into some memory element, or it may be a delay due to the wire, due to the communication delay. So let us go through the circuit block diagram of the sequential circuit. Here, this is a combinational circuits. If I remove this part, this total feedback part, whenever we give an input, n number of input, there are m number of outputs. So when we are using only the combinational circuit, then the combinational circuit is a function of present input. Now what happens? Here is a memory element. Then memory element, what memory element does? It records the past output. So here it should be the output, past output. So whatever is the past output, that is the previous output, that is stored in the memory element, and that is again fed back to the as an input to the combinational circuit. So we can say that there will always be a feedback in the sequential circuits, and this feedback may be with the help of a memory element or with the help of the wire, because wire always provides a delay. So in a whole, we can say combinational circuit, which output of the combinational circuit is stored in the memory element, and that output of the memory element is fed into the input to the combinational circuit, and the whole block is known as a sequential circuit. So sequential circuits, a synchronizing or periodic signal, that is clock, facilitates the transition from present state to the next state. Memory is provided with the help of flip-flops. So here are the clock pulses, and the memory element is replaced by a flip-flop. You can say this clock pulse is used for the synchronization of the whole circuitry. The clock you may consider as whenever you are buying a processor or a mobile phone, you always go to its speed. Suppose, what is the speed of your processor? 3 gigahertz. Yeah, 2.3 gigahertz. So this gigahertz is the frequency of the clock which we are using for the synchronization, and this is your clock pulse. This clock pulse synchronizes all the memory elements in the sequential circuit. So this is the type of clock we use for the synchronous circuits, and the clock is for the synchronization. So here is the logic level 1, here is the logic level 0. So 1 is here, 0 is here. When we go from 0 to 1, it is positive edge. When we are going from 1 to 0, it is known as negative edge. So there are 4 levels in a clock. Level 1, or we say level high. Level 0, that is level low. Positive clock, positive positive edge, and the negative edge. Now the NOR latch, here we have a cross coupled NOR gates. Here first input is R, that is R stands for reset. One input is S, that is set, there are two outputs Q, and remember Q is the output of the NOR gate, which has input R. So the output of the NOR gate is Q, and output of the S NOR gate is Q bar. And we have considered that the output is always complementary. Whenever Q is 1, Q bar will be 0. Whenever Q is 0, Q bar will be 1. So we have considered that the output are complementary to the each other. That is our first consumption, and we have done nothing but we have a cross coupled NOR gate. The output of the first NOR gate is input to the next NOR gate, and the output of the second NOR gate is the input to the first NOR gate. And the one input is R, stands for reset, one input S stands for set. We'll see in detail the process and how this works. So the concept is, for the NOR gate, if any input is 1, then the output is always 0, and this must be kept in mind. Whenever any input of a NOR gate is 1, then the output will be 0, and that is true for all type of NOR gates. So this is the table which we are going to discuss in the next slides. For now, we don't discuss it because it will create some confusions. So in this case, the condition SR equals to 1, 1 is avoided, and we are going to discuss how it happens. So whenever we cross couple two NOR gate, one input is R, one input is S, that is known as NOR latch, SR latch. Latch is a memory element which stores single bit in data. Now let us do the analysis of the SR NOR latch. Suppose this is the circuit. One input is R, one input is S. R is reset, S is set. One output is Q, another output is Q bar, and it states that as our primary assumptions that both outputs are complementary to each other. Now suppose the previous output is like Q equals to 1 and Q bar equals to 0. We have assumed that whatever is the previous input, this was the corresponding output. And suppose we have given R equals to 0 and S equals to 0. Now we go with our basic assumption of the NOR gate. For the NOR gate, if any input is 1, then the output will be 0. So keeping in mind the concept, we start our analysis for the NOR gate which has input 1. So here, this one will be fed back to the NOR gate with input S. So what happens? This one comes here. Because whenever a single input is 0, we cannot decide the output of the NOR gate. We need both inputs, or other, if any input is 1, then the output of the NOR gate will be 0. So whenever it happens, the one comes here. Whenever one input is 1, then the output of the NOR gate will be 0. This 0 is fed back here, and the output of 0, 0 for the NOR gate, whenever both input are 0, output is 1. So we can say this is a condition, means whenever both R and S are 0, 0, the present output is the previous output. Whatever the previous output, that is the present output. We can consider the another case. So here we can say, then whenever S equals to 0 and R equals to 0, Q equals to hold. Whatever the previous output, that is the present output. Consider the next case. Now suppose Q equals to 0, that means Q bar will be 1. In the previous case, we have considered Q was 1 and Q bar was 0. So in this case, we have considered that Q equals to 0, that means Q bar must be 1. And again, we have put it, the value of R and S equals to 0, 0. Again, we will start our analysis for the NOR gate, which has a single input is as 1. So here 1 is the Q bar will be fed back to here. Then the output of the NOR gate having one single 1 at the input, it will be 0. Now again 0 will be fed back to here, then S 0, another input is 0, then the output should be 1. So again we can say whenever R and S equals to 0, 0, output of the NOR gate or output of the SR gate is stored. That is, it is holding the previous output. Previous output was 0 and 1. Present output is 0 and 1. So again we can say whenever S equals to R equals to 1, the output is same, that is hold. That means it will store the output. Now consider another combinations. Suppose Q equals to 1 and hence Q bar will be 0. And now we have taken R equals to 1 and S equals to 0. What will happen? We will start our analysis with the NOR gate which has a single one input. So here for this NOR gate 1 input is 1. That means the output of the NOR gate will be 0. The 0 comes here due to the feedback, and whenever both inputs are 0, 0, output is 1. So we say whenever R equals to 1 and S equals to 0, the output is 0. We consider output as Q. If we say output is 0, that means Q equals to 0, then Q bar must be 1. Consider the another case. Suppose now the previous output was 0 and 1. And we have given the same input 1. Again, we will start our analysis with the NOR gate which has a single one as input. So, as R equals to 1, then the output of the NOR gate will be 0. 0 comes here. 0, 0, output will be 1. So, we can say in both cases, whenever R equals to 1 and S equals to 0, whatever is the previous output, in one case previous output was 1, in another case previous output was 0. But whatever is the previous output, the present output will be 0. That means this condition is known as reset. Output is reset to 0. And this can be seen here. Whenever SR is 0, 0, then the output is hold. Whenever SR equals to 0, 1, S equals to 0 and R equals to 1, output is reset. In both cases, we have considered both cases. In the first case, previous output was 1. In another case, previous output was 0. But whenever R equals to 1 and S equals to 0, the output will be 0. Now move to the next conditions. Suppose we have taken input as S equals to 1 and R equals to 0. We have, with the two inputs, we have four most possible combinations, that is 0, 0, 0, 1, 1, 0 and 1, 1. So here we are considering S equals to 1 and R equals to 0. And let us assume that the previous output was 1, hence the complementary output was 0. Our analysis starts with the NOR gate which has 1 as input. So here S equals to 1, then the output of the gate will be 0. 0 comes here. With the 0, 0 as input to the NOR gate, output will be 1. Consider another case. With the input combination 0 and 1, now suppose Q equals to 1, hence Q equals to 0 and hence Q bar will be 1. So again our analysis start with the same concept. As S equals to 1, output will be 0. 0 goes here. With 0 0 as input, output will be 1. So in both cases, considering the output Q1 as one time and considering output Q as 0 at another time, whenever S equals to 1 and R equals to 0, we say that the output will be 1. So this condition is known as set. That means output is set to 1. So this can be seen in the truth table. Whenever S equals to 1, R equals to 0, whatever is the previous output, in the present scenario, output Q will be 1 and Q bar will be 0. Consider another case, the last combination. Suppose Q is 1, Q bar is 0 and we have put it RS equals to 1, 1. And we have the concept that whenever single input to the NOR gate is 1, then output tries to be 0, 0. And that's not true, because it is the contradiction of the concept of complementary output. That means whenever we are using SR latch, we should avoid the condition of 1 1 as input. We can never use both input as 1 1. So this condition is not allowed. Again, with the 1 1 input and 0 as the output goes to 0 0, which is not true and cannot happen. So we can say that the condition with SR NOR latch 1 1 as the input, that condition must be avoided. This is disallowed condition. So in short, we can say whenever S equals to R equals to 0, the present output will be previous output. Whenever S equals to 0, R equals to 1, output will be 0. Whenever S equals to 1, R equals to 0, output will be 1. And whenever both input are 1, 1, this condition must be not allowed. So this is the analysis of the SR latch. Here we can see in the here we can see whenever S equals to 1 and R equals to 0, whenever S equals to 1, output will be set 1 0. Whenever S equals to 0 and R equals to 0, it will hold, it will store. So the previous output was 1, so 1 will be stored and here 0 will be stored. Now when S equals to 0 and R equals to 1, so what it will do, as R equals to 1, it will reset. So Q is reset, it resets from 1 to 0. Whenever Q is 0, then the Q bar will be 1. Again, when it is 0 0, so 0 0, it will store the previous value. Previous value was 0 and here is the 1. Now when input combination is 1 1, the both outputs goes to be 0 0 and SR equals to 1 1 is avoided. Output are not complementary, hence the transition from 1 1 to 0 0 may cause circuit to fall into either state or become metastable. So here we can summarize the sorry, SR NOR latch as with 0 0 input, output is hold. S equals to 1 and R equals to 0, output is set. S equals to 0, R equals to 1, output is reset, and 1 1 condition is not allowed. SR, again the same latch, SR, that is set reset with the help of NAND latch, and the process is same. We have a cross coupled NAND gate, and remember here in the previous case Q was the output of reset. When we are using NAND, Q will be the output of set and Q bar will be the output of reset NAND gate. And the process is same. We have cross coupled. Q is fed back to R and Q bar is fed back to S. And the concept we are considering here for the NAND gate output is 1 if any of the inputs are 0. Means if the single input of the NAND gate is 0, then the output of the NAND gate will be 1. This is the basic concept which we are considering for the analysis. Again, in the same way, we'll consider. Now suppose for the NAND output is 1. If any input is 0, we have to keep in mind. Suppose Q equals to 1. Q equals to 1 and Q bar equals to 0. And we have put it S equals to 1 and R equals to 1. So 1 does not define any value. So what happens? We have to start with 0. So 0 comes from here. This 0 goes here. Whenever any input is 0, output is 1. For the NAND gate, whenever input is 1, 1, output is 0. Again, consider with the different input is same 1, 1, and we have considered output as that previous output was 0 and Q bar was 1. So what happens? Again, our analysis will start whenever input is 0. So 0 comes from the feedback. Output is 1, 1 goes here. Then the output is 0. So in the both case, we consider that if SR equals to 1, 1, then whatever is the previous output, that is stored. In this case, whenever output was 1, 1 is stored. If the output was 0, 0 is stored. So we can say, so here I have inverted it instead of S and R, I have put it S bar and R bar. Whenever S is 1, 1, then the S bar, R bar will be 0, 0. So I am making similarity between SR NOR gate and SR NAND gate. So I have put it in the same manner. For the 0, 0 condition is hold. Whatever is the previous output, that will be stored in the flip-flop. With SR equals to 1, 1 or S bar, R bar equals to 0, 0. The concept is same. Now consider the another case. Suppose Q is 1, Q bar will be 0. Now here S is 0 and R is 1. So whenever S is 0, then the output will be 1. 1 comes here and the output will be 0. So we can consider again. Q is 1, Q bar is 0. Input is S equals to 0, R equals to 1. Whenever S equals to 0, then the output of the first NAND gate will be 1. 1 comes here. 1, 1, output is 0. Consider the another case. Suppose now Q equals to 0 and Q bar equals to 1. And the input is S equals to 0, R equals to 1. We start our analysis with the NAND gate which has a single 1, 0 as input. So whenever S is 0, output will be 1. 1 comes here and the output of the second gate will be 0. So we can say whenever S equals to 0 and R equals to 1 or S bar equals to 1 or R bar equals to 0, then the operation is set, means output in both cases will be 1. Whenever output is 1, we say it is a set condition, that flip-flop is set to 1. So here we can say S equals to 0 and R equals to 1. That means S bar equals to 1 and R equals to 0. Output is 1 in both cases. Either previous output was 0 or previous output was 1. Now suppose again Q is 1, Q bar is 0, and we have now considered S equals to 1 and R equals to 0. So we have to start our analysis where any input of the NAND gate is 0. So R is 0, that means output is 1. 1 comes here, then the output is 0. Consider the second case. If the previous output was 0, then Q bar will be 1. Input is same, 1, 0. Here comes 1. 1 goes to the feedback and the output is 0. So we can say in both cases, whatever is the previous output, but whenever R equals to 0, that means R bar equals to 1 and S bar equals to 0, then the operation is set. operation is, sorry, reset means output is 0 in both cases. So here we can consider with the help of table, whenever S bar equals to 0 means S equals to 1, R bar equals to 1, that is R equals to 0, then the output is 0, that is condition is known as reset. And the last case of the input, suppose previous output was 1 0 and we have put it S equals to R equals to 0, then the output of the both gate goes to 1. Again, it is a contradiction of the concept of complementary output. That means this condition must be avoided. And that is true for the previous, if the previous output was 0 1, 0 0 if the input, then the output goes to be 1 1. Again, this condition must be avoided. So in summarize, we can say if S bar R bar for the NOR gate, NAND gate is 1 1, then the condition must be not allowed. So in the case we can say we are using NAND gate, if S bar R bar is 0 0, condition will be hold. If it is 0 1 means R bar is 1, condition will be reset. If S is 1 and R is 0, condition is set, and 1 1 condition is not allowed, as in case of NOR SR latch. So I think we should stop our discussion here. In the next class, we are going to discuss how to control or how to synchronize these SR NAND and NOR latch, and we'll move further for some another type of latches and different types of triggerings.